Good morning, everyone. Today I'm going to present a topic from compiler design called handle pruning, which is an important concept used in bottom-up parsing and syntax tree constructions. In this presentation, I will explain what handle pruning is, how it works, and why it is important in building compilers. Let's go with the first slide. Here we discuss about understanding syntax analysis. Before understanding handle pruning, we need to know some basics. The first one is what is compiler design. A compiler converts high-level programming into a mission code using phases like Laxel analysis, syntax analysis, and semantic analysis. And also, what is parsing? Basically, parsing is also called as syntax analysis. Checks whether the program follows correct grammar rules and builds a construct structure called a parse tree. So basically, parsing ensures that the code we write is logically structured and meaningful. And in slide 3, we discuss about what is a handle. Basically, a handle is substring of a sentence that matches the right hand side of a grammar rule and can be reduced. There are three main parts. The first one is definition. A handle is reducible part of a string. And second thing is identification. We scan the string to find such patterns. And third one is reduction. We replace it with non-terminal symbol. For example, if we have a rule e extends to e plus t and the string contains of id, we can reduce id to e when appropriate. In simple terms, a handle is a part we reduce step by step during the parsing. In slide 4, we talk about the handle pruning core mechanism. Handle pruning is the process of removing handle step by step. It works in three steps. Locate handle, reduce, and repeat. In locate handle, find the correct substring. In reduce, replace with a non-terminal. And last step in repeat, continue until we reach the start symbol. This process reconstructs the parse tree from bottom to top. So instead of building from root to leaves, we build it from leaves to root. In slide 4, we discuss about key concept in bottom-up parsing. Now let's look at some important concepts. The first thing was rightmost derivation. This means we always expand and rightmost non-terminal first. In second, reverse process. Handle pruning works in reverse of the derivation. The third one is reduction steps. Each reduction steps brings close to the start symbol. So overall handle pruning is a basically reversing the derivation process step by step. In slide 4, handle pruning process. Let's understand the full process clearly. In initial stage, it starts with the input string and second step was handle detection. It finds the rightmost handle. And the third step was symbol replacement. Here it replaces it with a non-terminal. And the fourth one is iteration. It will repeat the process. And the last step was completion. Finally reach the start symbol. If we successfully reach the start symbol, the input is valid. If not, it means there is a syntax error. In slide 4, we discuss about syntax tree construction. This slide explains two important structure. The first one is parse tree and second one is syntax tree. In parse tree, there are three major points like it shows full derivation, includes all grammar symbols, and last thing was it can be large and complex. But in syntax tree, it is simplified version, removes unnecessary nodes. It mainly focuses on meaningful meaning of the program. Handle pruning helps in building syntax trees automatically during the reduction. So while reducing, we also construct the tree. And next slide, working example. Now let's see a real example. Like example, take grammar. E extends to e plus t by t. That means that converts to t extends to t into t f by f. Like f extends to e of id. Here input string is I plus id into id. Like we do in the step by step. If in first step id we transfers to f, and in next step f transfer to t, and next id transfers to f, and next t into f transfers to t. In final stage it goes to id transfers to f and then e plus t transfers to e. At the end we get the start symbol e, which means the string is valid. This clearly shows how to handle pruning work step by step. Now let's discuss about the practical problems. In these slides, we have some practical problems to understand better. Each problem gives a grammar, a string. You need to identify the handles, perform reductions, and build parse or syntax tree. These problems help in strengthening an understanding of handle parsing and handle pruning. Let's talk about the advantages and key takes. Finally, let's look into the advantage. Efficient parsing. No backtracking required, so it is faster. Tree construction. Builds syntax tree naturally during parsing. And next, error detection. If no handle is found, syntax error is detected clearly. Basically, there are four major key points. The first one is handle pruning reverses rightmost derivation. It reduces step by step. Builds syntax trees and from bottom to top. Uses LR parsers like SLR and LALR. Whether we have to check it is a LALR is right or wrong. So handle pruning is very important technique in compiler design. At last, we conclude this section. Like basically, handle pruning is a powerful method in bottom-up parsing that simplifies syntax analysis and helps in building efficient compilers. Understanding this concept is essential for everyone and studying compiler design. Thank you.